Hello and welcome. If you're new here, what you see in front of you is my 1/33rd scale model of Demon Drop. Demon Drop is a first generation Intamin drop tower at Dorney Park in Pennsylvania. It's kind of a hybrid between a roller coaster and a flat ride. I really like it, so I decided to make a model of it, and there's a little story to go along with that. I might tell you later. This video is to serve as an update of what I've done since I last showed this off. Last time I posted anything on the internet about this was December 2024, and it is now early May 2025. That has been, over 5 months. So I think it's about time that I update the world on the progress. Last time I showed this off, I had just finished what you see in front of you. There's been a couple tweaks and changes here and there since that time for this area, like this bar is new. But generally speaking, what you see is what I left off with. I just installed the cap, the track, the structure was finished. I even put in some little evac stairs that are, as some commenter on Reddit pointed out, not safe. And I know they're not safe. I won't be climbing them because they're tiny. But anyways, that's what I had installed. A couple pieces and parts have actually changed. I think this face actually I changed out since that video. I don't exactly remember what I showed off in that video. A lot of stuff has happened. And to briefly explain what I've done, I finished it. Yep, I finished it. I actually had to move back a little bit to get this thing in frame because it is really big and my office is really tiny. It's also got the landlord special down there and up there, so just ignore that. But yeah, I finished it. This thing is 4 feet tall by about 5-6 feet long, more like 5.5. Yeah, it's really big, and I can't even get the whole thing in frame, but mechanically, electronically, and all the controls, everything is done at this point. There's just a couple cosmetic pieces, and this thing is finished, and I'm very excited to show it off. So in this video, I'm going to take you through the last couple months, explain what I've worked on. I'm not going to get super technical in this video. I'm going to release one more video about this project as a whole in the next couple weeks that will get a little bit more technical and explain how it works, how I designed it, and all that stuff. So if you have any questions about that stuff, go ahead, leave it in the comments, and I will try my best to answer it both down there and in the next video. So let's go ahead and get into it. And then at the end of the video, I will give you a quick demo of everything working. Full transparency, right now I only have one test vehicle that I'm able to show off. The final vehicles are currently printing. You can see a couple here in the corner, up there. I have 3 more on the printer right now. So if you hear any kind of whining or buzzing sounds, that's either the air conditioner or the 3D printer running. But this is an unscripted and casual video, so you're going to get that a little bit. But yeah, the only thing left now in terms of things I need to 3D print are I have some cosmetic pieces to make a station roof over here, like that kind of looks like the real roof on the actual ride. I need to make a lid for the enclosure for all the electronics. I'd like to tidy up these cables as best as I can, but we'll see about that. And then I might try, there's these little Swiss cheese holes down there. I might try to plug those up a little bit. Those holes have a purpose. I'll explain later, but we'll see. Right after I posted the last video on YouTube, I dove straight into constructing the runout section of the ride. And, essentially, this model is built into 2 pieces. The first piece is what you see in front of you, and that is the entire tower section. That is all one piece. And then we have the runout section, which is the long part that is currently under the phone. The model is able to split into 2 pieces right about here. So if I need to transport this, or when it comes time for us to move, I can just separate out that joint and move it. It weighs probably about 10-15 pounds all said and done. I don't know. It's too big to weigh, but I've used about 7 kilograms of plastic, 7 kilogram spools. But of course, not all of that went into the model. Some of that did go into waste material. So it's hard to say exactly how much this thing weighs, but it's well over 400 parts, at least according to the SolidWorks assembly. That doesn't include fasteners. If I was to include fasteners, it's probably well over 500 at that point. Yeah, there's a lot of 3D printed parts, and most of this was printed on one machine. What you see in front of you, all the tower sections, the blue or teal parts with the exception of the stairs, and these cross pieces that are kind of hidden, you can't see in this angle, all those were printed on a Prusa XL. It's built out of 8 pieces that are combined into 4 sections stacked vertically. If you want to see how that was built, my last 2 videos show a little more in detail how I went about doing that. After I finished the tower, I went straight into the runout section, and I started that work in about late December, early January, and that took me well through March. There's a lot of parts for the runout section, but the first thing I did was I constructed the base pieces. All these whitish gray color pieces are 3D printed plates that are all screwed, and eventually they were glued together, with the exception of this seam right here is screwed together, so if I need to take it apart, it comes in the smaller chunks, but I don't want to do that, so hopefully I will never have to. But those are all 3D printed, which is something I would change in the future. I'll explain more in my next video of some things that I might do differently in the future, but don't 3D print base pieces. That just takes too much time, too much material, too much effort. There's a better way, and I'll explain that later. But yeah, that took me through mid-January, and then I started constructing all the actual structural pieces. There are 11 vertical segments, like here, 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 here. 11 of those. For the most part, they're all the same, with the exception of these two. These 2 large pieces were printed on the same Prusa XL that did all the tower segments. The rest of it was all printed on my machine, which is a Prusa Mark IVs. So I put a lot of printing on that poor little machine in the last couple months, but it handled it well. Each vertical section is connected to the one in front and behind it. So they're built from the tower down, and if I needed to, say for instance, remove this one right here, it's possible, but it is a little bit of a pain to get it out. Ask me how I know. But yeah, they're all built in a line down the model. They're all these sections are pretty much the same, with the exception of this one right over here, which is just off the edge of the camera. That's because the uprighting mechanism's there. Okay, we are now in about mid-March is when I started working on this. I had just installed all the track sections for the runout, so all these black pieces on the left and right side of the model. Those are pretty easy to install, so I did it as I went. And then it was time to start working on the uprighting section. So this is composed of a couple of mechanisms. For one, we have these 2 trap doors here on either side for each rail. Those trap door mechanisms got redesigned about 3 times, and I killed about 4 servo motors by just over rotating them and making bad mechanisms. So these this mechanism works really well, but that took a fair bit of time to just dial in and figure out exactly what I wanted to do given the space requirements. And I honestly don't really like the look of the 2 servo motors with the gears. You can see the one here, the other one's down here. I don't really like the look of those 2 servo motors just kind of hanging out there, but this mechanism works really reliably, and at this point I will take it. I just want it to work. Besides the trap doors, I also had the uprighting track. That was actually surprisingly easy to make. Now the cabins on my model, you can see the test one sitting right here, are a little bit different from the actual ride. So, and by different I mean the wheels are a little bit different. I couldn't exactly copy what they did on the real ride. It behaves very similarly, but the kinematics of how it uprights itself are a little bit different. But at the end of the day, it's the same idea. So, kind of copied it, but the geometry is different. But it works all the same. This little black tooth lowers it down. You have a motor down here that moves this tooth up and down. And then underneath this cabin, there is a belt there that is the end stop. I have a little bumper here, but it doesn't actually hit that bumper. But this belt is the end stop and triggers this Hall effect sensor right next to my finger that starts the uprighting process. So that took a couple of weeks. Started working on that mid-March, had it done early April. And that also includes the programming. As I'm going, I'm installing motors, sensors, wiring things up. That alone, all the wiring, if it wasn't for the wiring, I would have had this done in like probably late February. But wiring is a beast, as any electrician can tell you. So it doesn't help I'm not an electrical engineer. So as for all the electronic stuff and the control stuff, that's a little out of my comfort zone. I'm a mechanical engineer, so all this, the mechanical stuff, the 3D printed stuff, I can do that in my sleep. I had this model designed in about a month, and really the physical design has not changed very much with the exception of these trapdoor mechanisms and a couple other things. But for the most part, yeah, that was the easy stuff. The hard stuff and the more challenging stuff, again, was the electronics and the controls. But if you're not challenging yourself, you're not learning. And that's the point of doing these projects, is to learn. You may notice that these base pieces, there's holes in this one. And that's because, and going back to why you should not 3D print base pieces, these parts like to warp like crazy. They pretty much fill the entire bed of my 3D printer. And the geometry as such is just so that as it cools, it likes to curl up. And that gives you a really bad part. You don't want tacos when you're 3D printing. Yeah, that's some free advice for you. But this section here I had to redesign, and I was running pretty low on that filament. This is like a marble PETG that's, I wanted to make it look kind of like concrete. Didn't really work out very well, but I was running low on filament, so I actually split this part into two. You can see the seam here that have dowel pins that are used to locate the two pieces. And I glued them together, and I printed them, instead of this face being flat on the print bed, this face and this face was flat on the print bed. So they stacked vertically like this. And that helped a little bit. To give you an idea of how much filament I had left over from that, that is the same spool I printed that with. So not a lot of filament left. What I might do is 3D print some plugs, using this as like the first layer to cover up these holes, and then fill the rest with whatever else I have. And that should plug up the holes, make it look a little nicer. But yeah, I went through 4 of these to make these base pieces. I should have just got like a laser cut panel, and it would have been nice. It would have been just as expensive. Since we're talking about filament, the main structure itself, I used this Polymaker Teal PETG. This is what I have left of that. I've gone through about 4 or 5 spools, and this is what's left of the 6th one, I think. Something like that. I'll have to go through my Amazon history to double check that, but I went through a lot of this stuff, especially for the large sections that were printed on the Prusa XL. Some of the design of these parts is such that this was printed flat against the build plate. This face right here was printed flat against the build plate, but a couple pieces, mainly the larger ones, have these really tall skinny towers like this that were built vertically, and the 3D printer would occasionally clip those as it was moving and bring it all crashing to the ground. So I wouldn't say all 6 rolls of filament went into this project, but you know, that's how any 3D printing project is. You are going to have a little bit of waste, unfortunately. And then that brings us to the most recent progress on the model and what you see in front of you. So after the uprighting section was done, I really went in deep with the controls and the motion system for the ride. The tower is completely able to automatically lift the cabin up, push it forward, and drop it, and then reset itself after it drops. That was the first thing I assembled. And after I assembled that, I immediately realized there was another thing that I had to quickly redesign. There was actually 2 things. The first thing was the main tower motor, the one that's hidden all the way under here. You can't really see it. That motor is junk, and I was burning through those really fast. And that just simply comes down to the gear that pulls, or the pulley that pulls the belt that lifts it up. It was cantilevering the output shaft of the gearbox that came attached to that motor, and those gearboxes are junk. I kind of just assumed it would be okay because the Amazon listing showed it being used in RC cars. Don't buy technical stuff off Amazon. You get no data sheets, you don't get anything other than just it's a motor. I burned through about 2 gearboxes and decided, okay, I need to actually redesign this. So I redesigned the motor mount. It's really hard to see because it's all the way in the corner and I'm not moving this thing. But I'll show you a quick picture here. Basically, I redesigned it so we are no longer cantilevering that output shaft of the gearbox, and that takes a lot of load off that poor little motor. And so far, I haven't burned through any more, so that was a good investment of time. The other thing that I had to quickly redesign was the motors down here. I originally designed these to use little wheels, kind of like the actual ride has like trailer tires to move the vehicles around. I quickly realized that's not going to work because the little wheels were like 3/4 inch diameter, and that just does not give enough surface area to really grab onto the vehicles and push them forward. So what was happening was it would just spin, not do anything, make a lot of noise, but wouldn't push it forward. So these are actually little itty bitty belts using some O-rings down in here, and that works really well. You may have noticed a couple minutes ago, that's what I'm using on the hard stop, is what I'm calling it, at the end of the run out section. I'm using that belt as both a brake, and it is also what sends the vehicle back towards the uprighting mechanism, and that has seemed to work really well so far. Each motor is individually controlled, so this is where I have a blocking system like a roller coaster set up, where essentially each motor can have one vehicle on it at a time, and if it sees the one in front of it is not occupied, it'll roll it forward, but if it sees that the one ahead is occupied, it will stop the cabin and won't let it roll into the one in front of it. Just like a roller coaster. The controls on this are fairly simple, but works pretty well so far. The brakes did take a little bit of work to kind of finely engineer in such a way that it doesn't actually stop a vehicle, and I want that because just like the real ride, the main brakes here only trim the speed. It doesn't actually stop it because we need the vehicle to roll over the uprighting section. Because there's no brakes in here, we need it to have just enough momentum to roll over this gap and then stop behind it. We don't want to stop it over here because there's no way to recover it over there. So that did take a little bit of fine tuning, and this style of magnetic brakes, if you're new to my channel, I've done magnetic brake stuff before. I put them on a Connect coaster a couple years ago. That had mixed success. It wasn't super reliable. There's a couple things I would do differently knowing what I know now. But this system works really well, and this is very similar to another YouTuber who put magnetic brakes on his project, the Connect Maker, and I know he watches my video, so hello. The design of these brakes is pretty simple. On the back of the cabins, I have two magnets. They're actually stacked on top of each other, so you can't see the other one here, but there's two magnets there that just pass over with just enough gap here that it creates a braking force between the two, and that slows it down. And this is beautiful because there's no wear, there's no there's technically friction, but there's no wear of the printed parts, so that works really, really well. You can probably hear, it's hard to give a little demo, but you can kind of see it there. You'll see it in here in a second. And then there's actually a third magnet in these cabins. You can't see it because it's actually embedded in the print, so as part of the printing process, the printer stops right a couple layers up, and I'll put in a magnet before moving on with the print, and that locks the magnet in place. And that third magnet under here is only used for the ride to feel where the cabins are at. It doesn't do anything with the braking, so I didn't need it to be like super close or on the outside. Whereas these, every fraction of a millimeter counts, so that's why those are on the outside. But they're locked in by these blue pieces, so I'm not worried about them falling out. And finally, that leads us to where we're at now, which was just all the controls and the programming of the ride. So everything runs off a Arduino Mega. It's actually the same Arduino I used on my very first project that I posted back in like early 2022. I actually started that in mid to late 2020. So I've had that Arduino for a little while. At this point, it is now the Demon Drop Arduino because it is, we'll say I had to do some modifications to make it work. So it is now just a permanent part of this ride, and I will never take it out because getting it out, unless I absolutely have to, is a bear. I'm not going to show any of that stuff because it is shameful. All the wiring, all the soldering, all that, I'm ashamed of it. It is kind of gross, but I did have to learn how to make a custom PCB. So now that I know that skill a little bit, hopefully future projects might look a little nicer. That is something I'd like to come back and do in the future, is take all the electronics and stuff that I built for this and move it onto a single PCB. That will clean things up tremendously. But I spent a lot of money on this, I spent a lot of time on this, and I am ready to move on to other projects. The way the ride knows where each vehicle is at is there are little sensors. You can see them here. These black, here's one right there off on the bottom. These little black sections I'm trying to reach. Right here's another one right there. Those little black sections are Hall effect sensors, and they feel for the magnets that are on the vehicle. The Arduino reads a value that it puts off, and if that value goes past a certain threshold, it'll go ahead and trigger the ride and let it know that there's a vehicle there. But it is a couple lines of code, and each motor, I have the ability to, every single motor on this ride, turn it on and off. They aren't just like wired in series and turn on all at once. So that's pretty cool. You might notice I'm not running it right now, and that's because, like the real ride, this thing is very freaking loud. I'll play a video of it here in a second for you guys, but let's put it this way. I was concerned about it not being loud enough because the actual ride is very, very loud. But that's not the case. If you buy cheap motors and make cheap 3D printed stuff like move against each other, it's plenty loud, don't worry. So let me go ahead and play a quick clip of that for you.